Hello, in this video I'm going to demonstrate to you how we would set up the equipment for the physics PAG in combined science. We're going to be looking at the physics PAG where we measure the specific heat capacity. I've first of all set up a circuit involving a power pack, a voltmeter, an ammeter and a heater. And we'll talk about the heater being in the water and the thermometer in a second. The first thing you need to make sure you've got is a complete circuit. In series we should have a power pack, an ammeter, a heater and connecting back up to the power pack again. If we follow these wires, you can see the red wire connecting the power pack and the ammeter, the black wire connecting to the heater, and then connecting back over to the power pack over here. And I've connected my voltmeter in parallel, so I've plugged it in either side of the heater there. This is so I can measure both the current and the voltage of my circuit. My first job will be to turn on the circuit and measure the voltage and the current. So first, my voltage is 6.5 volts and my current is 2.05 amps. I'm then going to turn this off. Next thing I'm going to do is I'm going to write down and I'm going to note the starting temperature of my water. By looking at my thermometer, we can see that's around 28 degrees Celsius to start with. I'm going to write that down to make sure I've got it noted. I'm going to note those things down for later. I'm then going to get my timer, and when I turn my power pack on, I'm going to start my timer so I know how long I'm running this for. I'm going to let it run for 2 minutes, but I'm going to skip forward a bit so you don't see the whole time, because obviously watching the thermometer count up is kind of dull. So I'll start this and start the timer straight away. If I had two hands, I'd do them both at the same time. So after 5 minutes then, my temperature now has increased by 2 degrees C to 30 degrees Celsius. The voltage and current remain the same throughout. They fluctuate a little bit, but they did stay the same for most of it. It took me 5 minutes, and I stopped my timer exactly on 5, and I have an increase of 2 degrees C. So from that, I used 150 centimeters cubed of water. I have 28 degrees Celsius for my start temperature, 30 degrees Celsius for my final temperature, 6.5 volts for my voltage, 2.05 amps for my current, and the time was 300 seconds. I can use these to calculate the specific heat capacity of water by using 3 equations, which I can put together. The first one is I need to calculate the power supplied by my circuit. I'm going to do that by taking the current and multiplying it by the voltage. I also need to work out the energy that was used by my circuit after that. My current was 2.05, my voltage was 6.5 volts, so that would give me my power in watts, which I could then use in this equation. To work out the amount of energy supplied to the circuit over the time it was switched on, I take the watt power I've just calculated and multiply it by the time the circuit was switched on for. This would then tell me the total amount of energy transferred through the heater to the water or by the heater. I can then use that to work out the specific heat capacity by taking the total energy I used and dividing it by the mass, or in this case, the volume multiplied by the temperature change that I have. Okay, so I can put those numbers into the equation then, and I should find that the power would be 6.5 volts times 2.05 amps, which is 13.325 watts. I can work out that the energy is the power times the time, so that's 13.325 that we've just calculated times 300 seconds, which should give us 3,997.5 joules. And I can use that energy to work out the specific heat capacity. So energy is E, and I'm going to divide that by the mass times the temperature change. So that's 3,997.5 joules divided by 0.15 kilograms, because 1 gram per centimeter cubed is the same, 1 centimeter cubed is the same as 1 gram when it comes to water. We have 150 centimeters cubed, so we have 150 grams of water, which is the same as 0.15 kilograms of water multiplied by 2, gives me an answer of 13,325 joules per kilogram. The correct unit for specific heat capacity with 4,200 joules per kilogram per degree C. Now, the reason why I don't have that result is because the heater that I used was not transferring all of the energy from the circuit to the water. This was because it was not fully submerged in the water, and also it's because the water was not insulated very well. If I insulated the water well, energy would not have been lost from the water, and if I had the heater completely surrounded by the water, all of the energy would have traveled from the heater into the water as well. We would have got a better, more accurate result if we'd done those two things. Thanks very much for watching. Make sure you stay safe, stay alert, stay curious, and subscribe.